Hello guys, Assalamualaikum and a very good morning or afternoon depends on when you when you play this video, when you play this recording. Anyway, we have reached chapter 3 of our course, which is the kinematics part 2. This is still chapter 3, but part 2. So part 2, we will cover the motion of free fall. Free fall means somebody falling downward, or if we throw something upward and later it will come downward. Later it will come downward. So free fall means we are playing around with the y-axis, right? Free fall, we will play around again. Remember, free fall, we will play around with the y-axis only. Free fall, this is y-axis in the Cartesian coordinate. We will play around with the y-axis. Unlike free fall, the projectile motion, we will play around with both components, the x-axis and also the y-axis. Now, you have to remember this, especially those who haven't taken the physics course before. Free fall, y-axis, every vector component in our kinematic equation, for example, the velocity means the initial velocity, the final velocity, the displacement, also the acceleration. These 4 parameters, you need to turn them into y components. You need to only consider the y components of these 4 parameters: the initial velocity, the final velocity, the acceleration, and also the displacement. How about time? Time is a scalar quantity. We don't mind about the direction. We don't have any direction for time. So these 4 parameters, make sure when you are calculating or solving the problem involving free fall, you need to make sure all the parameters are in the y components. Now, how about the projectile motion? Projectile motion is a combination of the x-axis and also the y-axis. It means projectile motion, it moves like this. This is projectile motion. Something is moving from this side upward and to that side. So it's moving like that. It's moving from left to right or right to left, and also it's moving upward and downward. So it's a combination of left, right, up and down. So we will play around with the x and y component for the projectile motion. Now, so the learning objectives for this subchapter, we need to be able to explain the free fall and also the projectile motion using the correct physics principles. As I mentioned, free fall, only y component; projectile motion, x and also y component. It moves left and right or up and down. So it's a combination. You have to remember that. So we need to resolve the vector components. So the vector components that we have, the v, u, a, and also s. This v, u, a, s. We need to be able to resolve this component into x and y components for the projectile motion. So for the free fall, you need to be able to resolve into y component only. So VUAS for free fall, you need to be able to resolve and take into consideration of the y components only. But for the projectile motion, you need to be able to resolve and solve the x and also the y component. Salah. Gini. Ni x and also y component. So now, later you need to solve step by step the problems. For example, the free fall, the drop scenarios, something is being dropped from certain height and it falls down, okay? Or something that we throw upward and then it moves downward, or something that we throw downward and they continue to fall downward. We launch something with certain horizontal angle launches. We have projection angle, or we throw something horizontally, then it moves downward. So we need to take a look at 1, 2, 3, 4, 5 scenarios. You just need to remember, if it is free fall, y component; if it is projectile motion, if it is x and y component. Upward is positive, downward is negative, to the right positive, to the left is negative. As simple as that. Bear with me, we need to take a look at the examples, then we'll find out that they are not as hard as you think. Okay, and then we need to be able to interpret the motion graphs. There will be motion graph. For example, the y-axis is velocity, the x-axis is time. So we need to be able to understand or interpret the velocity versus time graph, or the position of versus time curves. Later we'll take a look at the examples. So first of all, okay, let's take a look. The first case, the free fall. Free fall, something is falling from a certain position and it moves downward. So free fall, free fall. So if we do the experiment, some of you have done this experiment before. If two objects, for example, feather and basketball, feather, we have a feather about this size and basketball about the size of our head. If we able to put them in a vacuum, vacuum means we have a chamber, an area, a space that we could suck out the air. Vacuum, nothing is inside the area except the feather and the ball. The oxygen, the molecules, the dust has been sucked out from the area. So that is the meaning of vacuum. And we have the second chamber on your right hand side. If we put the ball and the feather at the same space without sucking out the air, it means we have the atmospheric pressure, we have the dust, we have the hydrogen, nitrogen, carbon, all the molecules inside that space. Now, what will happen if we try to release the ball and the feather at the same time in a vacuum chamber? It happens to be the ball and the feather will fall at the same time. They will reach the ground at the same time. Why is that happening? Because there is no air resistance. There is nothing that could obstruct the movement of the feather and the ball downward. Nothing. No dust, no carbon, no any atoms. We have sucked them out from the surface. It's vacuum. Nothing inside. A vacuum in Malay is hampa. Hampa, nothing. Saya rasa hampa dengan kamu. Already feel nothing for you. Nothing for you. Orang-orang yang kecewa dah break baru 1 jam kan. Nanti jam yang kedua dia akan meroyan lah. Can we get back? Anyway. Right. So how about the second chamber, which in normal air? Okay. So we have everything inside. The feather, the basketball, the atoms, the molecules, the dust, everything inside, including mat lampe or mat limah whatsoever inside there. And if you try to release the ball and also the feather at the same time, it happens to be the ball will fall faster than the feather. Why? Because the movement of the ball cannot be obstructed by the dust, the air particles, the molecules, the mat limah, the hantu jerangkung whatsoever, because the mass of the ball is bigger than the mass of the feather. The feather, instead, the mass is very small, so it could be obstructed easily by the air, by the dust particles and whatsoever. So what obstructing the movement of the feather are the air molecules, majority. That's why it moves slower than the ball. But instead, in a vacuum, they will fall at the same time. So let's take a look the animation. You could try to click up, right? Or we make things even slower. So when we release, looks like they are falling at the same time, but as you can see, in normal air, the movement of the feather being obstructed by the air molecules. So there are air resistance present that opposing the gravitational pull by the planet Earth. So why do they fall? When we release something at certain height, why do they fall? Because from the Einstein gravitational concept, everything that has mass, they have this gravity pull. Yeah, stay in the skull. They have this gravity pull. So, long story short, okay, on planet Earth, we have gravitational pull. And the direction always to the center of the Earth. And from our point of view, looks like we are being pulled to the downwards. No matter where we are being pulled downward. Right? It's actually to the center of the earth. So what we are seeing is the earth is pulling us downward. And because it is pulling us downward, therefore the direction is negative. I know some textbook mention that gravitational pull, the value is positive, but you are in my class right now, it is better if you stick to this concept. Gravitational pull, downward, the direction is negative. Gitu. And the value, if you're able to measure the value of the gravitational pull, it is actually acceleration. The acceleration is 9.81 meter per second square. Almost constant at any location on the planet Earth. As long as it is Earth, then your gravitational acceleration is negative 9.81 meter per second square. Other planets, they have different gravitational pull or gravitational acceleration. On the moon, for example, the gravitational acceleration is much lower than negative 9.81 meter per second square. That is why sometimes the objects seems like weightless at the moon because the gravitational acceleration is very small if you want to compare with that of the Earth. All right. So why we fall down? Because we have gravitational pull. Planet Earth is giving on us. That's why we feel heavy. We feel wants to fall down. Nobody's falling upward or sideways. Nobody we fall downward because of the gravitational pull. Right. So we look at our next slide. Okay, this one. Before this, you have learned three important kinematics equations. The Vutat, the Sutat, the Vuzas that I've mentioned, which I mispronounced in my previous class. I'm sorry for that. It won't happen again. So remember, from the Vutat, or V equals to U plus AT, or from the Sutat, S equals to UT plus half AT square, or from the Vuzas, V square equals to U square plus 2AS. So in free fall, we use these three same equation. But because free fall only involving the Y component of the vector quantity. So all the vectors quantity in these three equations, we need to add Y. There is no value for the Y, but we just want to mark that the component that we are trying to calculate or we are trying to do the mathematical operations are the components of the Y axis. Yeah, free fall again, free fall from up to down, it is Y component. So make sure the one that we are calculating in the mathematical operations are the Y components, the Vy, the Uy, the Ay, the T. T, there is no Ty because T is a scalar quantity. Scalar quantity doesn't have any direction. So we only have Vuas that has the X or Y component. Same three equations. Remember Vutat, Vuzas, and Sutat. You will be happy throughout the chapter 2 and 3. Right? So the sign convention, as I mentioned, upward positive, downward negative. That is why the gravitational acceleration I wrote over there, it's negative 9.81 meter per second square. So your equation always plus sign. There are textbooks that using negative sign, but it will be very confusing. We stick to these three formulas. We just add X or Y. We don't disturb the sign convention. I mean the mathematical operation. We use plus sign throughout the course. Don't compare with RK1, RK2, or RK5. They are using some other equation, which is very confusing. You don't even know when to use which one, when to use plus or when to use minus. So in my class, we use only three simple equations. We don't change the mathematical operations from plus to subtraction. No, we don't. We just need to identify which components they belong to, X or Y. That is it. That is all. Right now, let's take a look at the next. See, this is the graph that I mentioned before. Okay, we have the first graph, V versus T. The x-axis is time, the y-axis is v. The positive side of this one, the positive side of the velocity, okay, is located over there. It means that your velocity is positive. Maybe you are moving to the right, maybe, or maybe you're moving upward. Now, this is the negative side of the velocity. Maybe you're moving leftward or downward. It could be like that. How about the time? Time don't have any direction. Anytime, following your stopwatch. So, again, you need to remember these three equations only: Vutat, Sutat, and Vuzas. And be very extra careful with the sign convention: upward, downward, leftward, and rightward. Okay. So if you have this kind of graph, the VT graph, the velocity versus time graph, the area under the graph could be calculated, and they are actually the S. What are the S? Sorry, what S? Sorry, what are the S? They give, they will give you the displacement. The area under the graph is the displacement. V, graph V and T, the area under the graph is the displacement. How about the slope? The slope, if you're able to calculate, this is mathematics. This is mathematics. I'm just continuing whatever you have learned in basic mathematics before. So the slope is actually our acceleration. And for our case, in free fall, they are gravitational acceleration. So the AY will give you the AY. And AY is our gravitational acceleration. You could use AY or you could use G. So the AY over here, that are stated over here, for free fall, AY is our gravitational acceleration. AY, the acceleration at the component of y-axis. We only have one acceleration, that is the gravitational acceleration. And for free fall, AY always gravitational acceleration, even though the question doesn't mention, but automatically when you see free fall cases, AY automatically is negative 9.81 meter per second squared. Now, this is the tip for free fall. You look at the question, if it is free fall, AY is our gravitational acceleration. It is negative 9.81 meter per second squared. And please don't use 10. I know that in SPM, they used to use G is 10 meter per second squared. No, do not use that one. We go a little bit detail. It's negative 9.81 meter per second squared. So the area for VT graph, the area under the graph, whether it is positive or negative, so the area under the graph is the displacement. The displacement could be positive, which means maybe you're moving upward or leftward or rightward, or it could be negative, which means you may be moving to the leftward or downward. And the slope given will be our G or AY, and it is gravitational acceleration. It's negative 9.81 meter per second squared. Okay, this is easy. Let's see the example number one. An object drop from rest. Drop means like this. This is drop, and not throwing something down. That is not dropping. Dropping means you release something from certain height. That is drop. Throwing something is throwing downward or throwing outward. That is not drop. Okay, the first case that we are seeing right now is dropping something from certain height, and the object initially wasn't moving. The object is not moving initially. So if we look at the U of this object, it is being dropped from rest. So the initial velocity for this object when it's being dropped is 0. See, drop. If you see something, if the case of the physics is drop, it means that your Uy equals to 0 meter per second. Why Uy? Because it's free fall. Something being dropped, it will fall downward and not sideways and not upward. It falls downward. And initially, the object that is being released is not moving because you're holding the object. It is not moving. When it is not moving, therefore your Uy is 0 meter per second. even though the question doesn't tell you about this, but automatically you see the object drop, uy 0 meter per second. Now, this is the second parameter that you automatically will know. The first one is ay is negative 9.18 negative 9.81 meter per second square, even though the question doesn't tell you, but you have to remember that. And if the object is being dropped, automatically your uy will become 0 meter per second. Please do watch my videos. Don't wait until the day before the test or examination you want to watch. Therefore, it's very hard for you to comprehend whatever I'm trying to tell you. Right? So we have these two parameters. And if you want to study, if you want to find the position and the velocity, position here also could be equals to the y displacement. We want to know when we drop something, we want to know how far this object has fallen down after a few seconds. We could calculate that. We drop something, or we see people being dropped from the 15 tingkat 15 jatuh ke bawah. Okay, I want to calculate at the 3 seconds where will be his position. So you could calculate using the SY. And remember, whenever something is fall down, your SY, you could predict that the value will be negative. Because why? Because displacement of falling object, displacement always downward. So your SY must be negative. The only thing is that you haven't calculated it yet. You just don't know the number, but you already know the sign of your SY is negative because it falls downward. And SY is displacement, the shortest distance from the initial position upstairs and the final position downward. Of course, the direction will be downward. Your SY will be negative. So this is the third thing that you already know before you try to solve the drop cases. And how about the velocity? Easy. You fall downward, your final velocity also will become negative. This is the fourth predictions before we even started the calculations. Okay, now, maybe you want to know, okay, what is his position and velocity at 1 second, 2 seconds, 3 seconds, or even 5 seconds. You want to know the position and the velocity of the fallen object. So the options of equations that you have, you only have 3 equations: the Sutat, Vutat, and Vuzas. You need to be able to play around with these 3 equations. So for this case, there's no specific tips and tricks which equations you have to use. You have to do trial and error. You have to do trial and error. Only 3 equations, very easy. Okay. So Sutat, Vutat, and Vuzas. And remember, all the vector quantities, the VUAS, V, U, A, and also S, you need to transform them into Y component. First, rewrite the Sutat, Vutat, Vuzas by incorporating the Y, the apa ni, sub apa nama dia? Subtext, not subtext. What is the word? Whatever it is. The SY, the UY, AY, and also VY. You need to put that. Right? Indicate that we are playing with the Y component of those 4 parameters. So how do we try to solve the first question? We want to calculate the position and the velocity at the first second. So use Sutat. For example, you have to try trial and error. We try to use Sutat. S, we want to calculate S. We want to see where is the position of that object at 1 second. How about U? U is 0 meter per second because the object is being dropped. 0, kat sini, 0, right? How about T? Yes, T, we want to calculate the position of the object at 1 second. 1 second kat sini. Okay, half is half. How about AY? AY is gravitational acceleration. At the y-axis, only gravitational acceleration is involved. So the value is negative 9.81 meter per second square. And how about this T square? T is equals to 1, so T square equals to 1 square. Sekejap anak saya nak masuk bilik. Dia nak berak pula. Aduh, serabut lah. Next time berak at 6 AM ah. Don't kacau abah. Okay, go. Jangan togel kat sini. Bilik. Sure. Okay, so plug in all the parameters and you will get your value is negative 4.91 meter. So negative betul ke? Yes, betul lah. Because displacement, it has magnitude and direction. So the magnitude is 4.91 meter and the direction is negative, which means it falls downward. Yeah, it's true. You release something, it falls downward. Your SY should be negative. See? The number tells you the direction already. But if the case is drop and your SY is positive, something is not correct with your calculations. Look at your calculations. Again, it's not logic. Somebody falls upward. There's no such thing. Maybe you forgot to put negative in the acceleration, in the gravitational acceleration, most probably, right? So how about we want to calculate the velocity of the fallen object at 1 second? You can use Vutat or Vuzas. So in this case, I try to use the Vutat. So V equals to U plus AT. We transform it into Vy equals to Uy plus AYT. The VUS must be put the Y component over there. Just plug in V. Okay, V. We want to find out V. How about U? U over here is 0. Initial velocity is 0 because the object is being dropped. Plus AY. Our AY is gravitational acceleration. It's negative 9.81 meter per second squared. How about T? T is 1 second. And there you go. You got your velocity at the first second is negative 9.81 meter per second. Okay. Later we try to play around with this simulation lah, kan? Later we play around. So same goes for if we want to calculate the position and the velocity of the falling object at 2 seconds and also at 3 seconds, we still going to use the same equations. The three equations, most powerful equations in kinematics, Vutat, Vuzas, dan Sutat. These three kinematics equations only. So I again remind you, do not use during the test and examinations, and there will be two parts of equations. We will give you, the lecturers will give you the equations that you need to use. You're going to need to use the equations. But for RK3 and 4, or everybody in my class, they need to use my appendix. I will put there in the appendix. This is only for RK3 and RK4. Use my equation. Do not use equations from some other lecturers. You are using different equations. But generally, they will get same answer. But the way you want to memorize for the other lecturers' technique, for me, it's very time consuming. We don't have that time. We don't have the luxury of time in our examination. So cut short, please use my equations. Jangan togel sini. Okay, dah pakai slow. Okay, good. Nah, go outside. Go. Shh. Disturb your mom. Okay, so try using these time 2, time 3 second at your own pace lah. Nanti cuba sendiri. So let's try to play with the interactive simulation. Okay, how about time? Apa? Kita boleh adjust. Pada satu saat, mana satu saat tadi? Adjust satu saat. Lah, terajak. Susahnya nak jadi satu. Tarik sikit. Terajak. No. Susah agak nampak. Let's say lah, Pak. When the time is reaching 1 second, see your SY ni your SY, when time is reaching 1 second, your SY nearly the same with the SY of 1 second. Sebab saya susah nak adjust time exactly 1 second ni. Kan? How about the velocity? The velocity also menghampiri lah velocity dia from 9.81 becomes 9.42. Ni kan, hampir. But if we able to adjust 1 second over here, definitely your SY and VY will be equals to these two. Dia akan equals. So sukar kita nak adjust ini. Try. Dia semakin mendekati kan. Kan? It's 0.98 second. Your SY is already 4.71. Yang ni already 9.61. Menghampiri lah. Yeah, how about 2 second? 2 second. 2 seconds. Oh my. 2 seconds. Nearly the same. Sini. Nearly the same. So nanti test, we don't have this simulation during the test. You need to be able to calculate. Calculate using this equation, the kinematic equation. 3 equations only. You don't need to memorize because I will give you the 3 equations. But if you want to memorize, it's better. But if you don't want to memorize, you have to look at the correct appendix. Find the appendix for RK3 and RK4 only. Do not use the RK1, 2, and also 5 because they are using complicated formula that you couldn't even pronounce it. All right. Anyway, look at the second example. Second example. An object is being thrown downward. The object is being thrown downward. What is the time? Never mind. Now, example 2. Thrown downward. The keyword is thrown. Ataupun if the question gives you the initial velocity of the object. When something has initial velocity, it means that the object is being thrown. If the initial velocity is positive, Uy is positive, it means that your object is being thrown downward. The object is not being released. It's not being dropped. If dropped, your Uy is 0. It's not moving initially. But if you throw something downward, you are giving the initial velocity negative. It means it goes downward. So Uy. So these are the keywords. Thrown downward, or your Uy is negative. If thrown upward, your Uy will be positive. If thrown sideways, therefore it is not a free fall. Instead, it is the projectile motion. Throw something downward, your Uy is negative. Throw something upward, your Uy is positive. Throw something sideways, that is not free fall. That is projectile motion, which will be covered in the second part of this lecture. Uy is still the same because it is free fall. It is negative 9.81 meter per second square. And time that you want to try to calculate the parameters at 1 second and 2 seconds, or any time that the question will ask you. So for this case, we want you to calculate the displacement and the velocity at first and second. At the 1 second and 2 seconds. All right. So the equations, the same 3 equations, Sutat, Vutat, Vuzas. Those are the only equations that you need to work with in chapter 3. For my class, 3 equations only. But for the other classes, they are using tons of equations. 3 to the power of 3. 3 kali 3, 9. 9 kali 3, 27. 27 equations that you need to memorize for me, for my class. 3 equations only, guys. 3 equations only. You just need to modify whether it is X or Y. So for our case, free fall, all the vector quantities, you need to put Y. Because it's free fall, whether upward or downward only. Right, now the solution. Okay, this is the visualization of the free fall of something being thrown downward. See over here, this object, this ball is being thrown downward. That's why your Uy is negative. Remember, throw downward, negative lah, kan? So the time taken over here, this is the initial starting point. The time is 0. That it moves downward at time 1 second. You need to be able to calculate the Sy and Vy. Why? Because the question asks you to calculate Sy and Vy at 1 second. What is Sy? The displacement or the position of the ball after it is being thrown downward for 1 second. So after 1 second, we want to know where is the location of the ball and what is the velocity of the ball. So you use Sutat or Vutat or Vuzas, play around with that. plug in all the parameters. Let's say you choose VUSAS and you find out you're missing one parameter, you cannot go, you cannot calculate anything. So change to some other equations. You will have three equations to play with. Change to second equation. Sometimes you might accidentally calculate the velocity first. Doesn't matter. There's no sequence. You must calculate the displacement first or the velocity first. It's up to you. It's your test exam paper. You can calculate the velocity first. You want to calculate the V first. Go ahead. Right? So for my case, I calculate the displacement first using SUTAT as y equals to uy, because this thing is being thrown downward. Your uy is negative. Okay, t depending on the question, they want you to calculate t at 1 second, put t 1 second, and half ay is negative 9.81 meter per second square. Remember, guys, I know most of you will do this error. Do not forget to put the negative sign for the gravitational acceleration. And I know, I definitely know, less than 50% of students will watch my video. It's up to you. You are the students, I'm the lecturer. You don't want to watch, it's up to you. The risk is on you, not on me. All right? Half a t square. Be careful. T, most of the time, people will forget to put square. If the time is 1 second, doesn't matter, because 1 square is always got 1. So the value of your SY is negative 7.91 meter. So it's true. Something is being thrown downward. The value of your SY should be negative and not positive. How about VY? So I use VUTAT. This is VY equals to UY. UY again, it's negative 3 meter per second. Do not forget the negative sign. Plus, this is AY. AY, or gravitational acceleration, is negative 0.981 meter per second square. And T is 1 second. So you got your velocity at 1 second is negative 12.81 meter per second. So this is logic because the object falls downward. So your velocity should be negative. But if the question asks you about the speed of the object, you need to change. Your calculation should be negative. Your calculation is negative. Okay. And then you put one statement at the bottom. So therefore, the velocity that has been calculated is negative 12.81 meter per second. Therefore, the speed of the object is 12.81 meter per second. You make it positive. Okay? If the question asks you about the speed, you just need to change the sign because the speed doesn't have any direction. So it will become always positive. Just change that. So how about for the 2 second? Same equation, same method. The only thing is different answer. So play around with the equation. Do the calculation at your own time. You will get the same answer as me. Right. So next, example 3. This time the object is being thrown upward. We throw something upward, therefore our UI is positive. Thrown upward. The object is being thrown upward. Your initial velocity is not 0. It's not negative. Instead, it is positive. Yeah, you throw something upward. It is still free fall, but the first leg it goes upward. You push. You throw something upward. Your UI will be positive. So if something is being thrown upward, your UI is positive. For example, for this case, you throw something upward 15 meter per second, positive. Your gravitational acceleration doesn't change. Always negative 9.81 meter per second squared. So one more thing. So after you throw something upward, something goes upward and upward and upward. At the peak of the motion, the velocity becomes 0. The Vy becomes 0. It goes upward and it stops for a while and it goes downward free fall. So at the top, when you throw something upward, at the top, the velocity becomes 0, then it moves downward. So that's the case. At the peak, at the top of the movement of the object, after it is being thrown upward, it will stop for a while. Therefore, its Vy becomes 0 meter per second at the top. Okay, so now I might ask you, what is the maximum height of the object that you have thrown upward? The maximum. I can ask that question. And something is being thrown upward. I might ask you, okay, how high have you thrown that ball upward? We will also want to know. When you throw something upward, we were wondering, berapa tinggi dia boleh baling ke atas tu? So we could calculate that using the SY formula. You could use the Sutat or the Vuzas, the two equations that contain the displacement information. Height. It's about it's not about Vy, it's not about Uy, it's not about Ay, it's about Sy. We have only VUAS. So the height can be calculated using Sy. So we only have two equations that has Sy. It could be Vuzas, it could be Sutat. So for this case, I'm going to try the Vuzas. V square equals to U square plus 2AS. So in this case, because it is a free fall, we use Vy square equals to Uy square plus 2Ay times Sy. All are vector quantities. We don't have any time in this equation. All are vectors quantities. So step one, set peak condition. Remember, when we throw something upward, it goes upward, then it stops for a while. At the peak, our Vy is 0. So this is clue. This is a clue. It stopped for a while, therefore we have a clue. Vy is 0 meter per second. The Uy is not 0 because we are throwing something upward. Uy is 50 meter per second square. Sorry, 50 meter per second. Then it goes upward, then it stops. At the peak of the motion, your Vy equals to 0 meter per second. That is the clue for you. So we already have, if you look at the equation, our Vuzas equation, Vy, we already know this is 0. Uy, also we already know that this is 15 meter per second positive. So we just need to find out the 2AS. We want to find the Sy. Because we want to know the maximum height of the ball that is being thrown outward. So we need to find out the Ay. Ay is still gravitational acceleration. For free fall, Ay is always the gravitational acceleration. Ay is our G. Okay, so therefore we already know all of the unknown parameters. Vy we know, Uy we know, Ay we know, then we can find Sy. So plug in all the parameters. 0 square, 15 meter per second square, plus 2 times negative 9.81 meter per second square. Then we can find the Sy. Right? So the Sy means 11.47 meter. Because why? Because we want to know the top position of the ball being thrown upward. We don't care about the movement of the ball going downward after this. We just want to know this part of the motion. The ball goes upward, 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 and it stops for a while. And we want to know what is the height of this ball from the initial position over here. We want to know what is the height of the ball. Okay. The ball will consequently falls down. What we don't care, for this case, we don't care about that motion. We care about the first leg of the motion when the ball goes upward. Therefore, your calculations over here is legit because we don't care about the second leg. The second leg is the ball when the ball goes downward. We just want to know how high the ball moves upward. Therefore, your Sy is positive. That is logic. Your Sy is logic because we just care about the first leg of the movement. It's 11.47. That's it. That's it. That is all. Guys, that is all. It's 11.47 meter. So it's logic. Now, let's try to see any other example. Example 3B. Ini dah slide ke berapa? 1, 2, 3, 4. No. 3B. 1, 2, 3, 4, 5, 6, 7, 8. 3 more slides to go. 3 more. 3 more. Bear with me. 3 more slides to go. It's it's super easy. But please do watch my videos. Watch my videos. If you don't watch my videos, it's very hard for you to understand, to comprehend whatever I'm trying to teach you. Okay, now, example 3B. something is being thrown upward. Okay, something is being thrown upward. We know the initial velocity will be positive and it will move upward. At certain point, it will stop. At this point, the final velocity becomes 0. Okay, we know that. Right now. But this time, we don't want only the first leg. We want to know the first and second leg. The ball is thrown upward, and the balls will fall down. So this is the first leg, this is the second leg. We want to know both of the movement, the first leg and second leg. Okay, so this is the, so if this is the case, the ball goes upward and goes downward, it means that a complete movement of the ball. The ball from your hand, you throw upward and it goes downward again. This is the complete set of the movement. It means that the ball, this is the initial point of the ball, goes upward and goes downward. This is the final point of the ball. As you can see, the ball comes back to its original position. Your displacement will become 0 because the ball, the shortest distance between the initial point to the final point is 0. This is the initial point. This is the final point. Looks like the ball is not moving. Looks like the ball is not moving, even though the ball is moving, but because it comes back to its original position, the SY, the displacement on the y-axis is 0. The ball doesn't move at all. Looks like the ball doesn't move at all. But even though the ball is moving, but the position is still the same. The shortest distance between the initial position to the final position is 0. See? So for this case, 3D case, 3B example, your initial point, your displacement will become 0. But your AY still negative 9.81 meter per second square. Doesn't change. Yeah. So if you have this case, I could ask you to find the time from the initial position to reach the peak. And I could ask you the time of flight, means from this position to that position and to this position again. I could ask you the time of flight. Okay, first I could ask you about the time taken for the ball to reach the peak. I could ask you, or I could ask you the time taken for the ball to reach the peak and to come back to its initial position. Okay, or I could ask you the time anywhere in between those events. For example, at certain second, I want to know what will be the time. At certain displacement, at certain location, what will be the time? So if you have, let's say, a ball was thrown upward 15 meters per second. Calculate the time taken for the ball to reach the peak of the motion. That is question A. Question B, calculate the time of flight of the ball. It means the total movement of the ball. And C, calculate the time when the ball reached 8 meters from the ground. Listen to my question carefully, especially question C. Calculate the time calculate the time when the ball has reached 8 meters from the ground or from the initial position. So three equations. Saya tak tahu kenapa saya listkan 2 saja sini. But remember, we have 3 equations to play with. Vutat, Vuzas, and Sutat. Okay? There is no specific tip. Oh, question A, you must use Sutat or Vutat. No, you have to do trial and error. Sampai you dapat jawapan. Okay? So, for the first case, I'm using the Vutat. Vutat. Why? Okay. Remember, time taken for the ball to reach the peak. Sini. Ball pergi naik atas sampai ke peak. At the peak, remember at the peak, your velocity becomes 0. Your V becomes 0. So that's why I'm using the Vutat. The first one, Vutat. Why? Because Vy, we know, becomes 0. How about Uy? Uy is given from the question. This is Uy. But question kat sini, Uy dah bagi. How about AY is our gravitational acceleration. That is gravitational acceleration. Therefore, we could calculate T. Because we already have Vy, Uy, and Ay, we could calculate our T. It's straightforward. So our Vy is 0, our Uy is positive 50 meter per second, our Ay is negative 9.81 meter per second square, and our T can be calculated. It is about 1.53 seconds. So the time taken for the ball, whenever it is being thrown upward, the time taken for the ball to reach the peak, whenever it stops for a while at the highest peak, the time taken is 1.53 seconds. So how about the total flight? How about the total flight? How about the time taken for the ball to come back to the ground? You have two methods to calculate. Okay, one, it's just simply, the half movement is 1.53. Okay, to finish the movement, you have to add one more 1.53. So it is about 3.06 seconds. I accept that calculations. Or if you want to use the equation, you can use the Sutat. Okay, you can use the Sutat. Okay, S equals to 0. Sy equals to 0. Why? So why Sy equals to 0? See, the movement of the ball, it goes upward and it goes downward. See, it comes back to its original position. Your Sy will be 0, as I mentioned in the earlier second. Right? Sy will become 0 because why? Because it comes back to its original position. That's why your Sy over here is 0. How about you? You the same, you given in the question, 50 meter per second. How about T? We don't know the T, sir. We want to calculate the T. Okay, never mind. Half Gy. This is Gy or Ay. It's negative 9.81 meter per second square and T square. So you have quadratic equations. You have over here is negative 4.0 berapa? 9.81 bagi 2 berapa? 4.905. Negative 4.905 T square plus 15T equals to 0. You have to use your scientific calculator and solve this quadratic equation. You will find out that your T is 3.06 seconds. Same value. You could use the Sutat or you could use the times 2. 2 times 1.53 seconds. You could use that as well. You're allowed to do that. And next, I want you to calculate the velocity of the ball when it just want to reach the ground. After the ball reaches the ground, the velocity is become 0. Just before it reaches the ground, what is the velocity of the ball? So you could try out the Vutat. Okay, you want to calculate the final velocity of the ball here, not there. There, the final velocity is 0. How about here? So Vutat, V equals to U is plus 15 plus AT. This is A, negative 9.81 meter per second square. Darab dengan T. T is 3.06. Kat sini, T adalah 3.06. So you got negative 50 meter per second. This is the velocity of the ball just before it hits the ground. That's it. Alright, now, final question. Lepas ni kita stop sekejap. Final question. Nanti kita sambung example 4 and onwards. Kat sini, last slide lah. Last slide. Kita berhenti dekat slide ke-9. Alright. So now, you need to calculate the times when the ball is 8 meter above the ground. So this is the point. This is 8 meter above the ground. The ball moves upward. It reaches 8 meter. This could be our answer. But wait up. The ball goes upward again and reach the pinnacle top. And it goes down back again. This is the second position. This is second time the ball reaches 8 meter. This will be our second answer. So we will have two answers. The first one is this one, and the second one is this one. So we need to calculate the times. There will be 2 times the ball will reach 8 meter. First, when the ball goes upward, and the second one, when the ball goes downward. it will reach the position of SY equals to 8 meter. So we could calculate the time using this one. Huh? Using SUTAT. SUTAT, we know SY is 8 meter because the question asks us to do so. Calculate the time taken when the ball reaches 8 meter. It means 8 meter could be our displacement. 8 meter from the ground. We put 8 meter in the S. How about U? U is 50 meter per second, as given in the question. T, we don't know T. We want to find out what are T's. Half, okay, negative 9.81 meter per second square times T square. So we have a quadratic equation. Use your scientific calculator use your scientific calculator to solve these quadratic equations, and you will find out that you will have two answers, 0.69 and 2.37. That is correct because your first leg over here, your time taken is 0.69. It goes upward, it goes back down. Over here, your time is 2.37 seconds. Both are correct, and you have two answers for that. So that is all for the first part of the lecture. We continue on example 4 after this. Thank you.